We are now in the second half of our systems of equations unit, and now we're going to start looking at what happens if I have non-linear functions involved in my system. So we're going to go through 5 or 6 examples together. The first one, we have been given an exponential function and a linear function. And the first question for us is how many solutions there are to this system. So I'm going to switch over to Desmos. And I've already zoomed out a little bit on this picture so that you can see it a little bit better. We have 2 solutions here. I have one up here and I have one down here. So the answer to part A would be 2 solutions. And the second part of the question is for what positive value of x does f of x equal g of x? And since it says f of x equals g of x, that tells me I'm looking for their intersection or where they are equal to each other. So I want the positive x value. Well, this one is not positive. This is a negative x value. So I'm going to go to the other intersection point, and it says round to the nearest hundredth. So that means I want 2 decimal places. So my x value would be 3.40. And that would be the positive x value where f of x is equal to g of x. Now, it is possible for an exponential function to have 1 solution or no solutions. 2 is not my only option. I could have a horizontal line that came through this way, and that would be my only solution. No solution, if this was -6, let's say, instead of +46, now no matter how far I zoom out, these are never intersecting. So that's another possibility for exponential and linear functions. So we're going to move on to question number 2. And this is asking us, again, how many solutions there are in the system. And now I have a quadratic with a linear. So I'm going to come back to Desmos. I'm going to close out that first question. So here you'll see that here's my quadratic. Oops, don't mean to move Desmos. Here's my quadratic, that U shape, the parabola that we talked about. And then here's my linear function. So this, again, has 2 solutions. And the second part of this question is asking for the sum of the x values where my functions are equal to each other. So I need both intersection points, and I need the x values for both intersection points. So I have -3 and +1. And since it's asking for the sum, I have to add these 2 things together, because these are my 2 x values where my quadratic and my linear function intersect. So the sum of these 2 things together is going to be -2. So then, moving on to another quadratic and a linear, we're going to look at the difference between question number 2 and question number 3. If you look at this parabola and this linear function, no matter how far I zoom out, and I could keep going forever, I'm already in the thousands. These are never going to intersect. So if I zoom back in, you can see that the vertex of the parabola never comes down close enough to intersect with that linear function. So this is no solutions. So it is possible for an exponential and a linear function, or a quadratic and a linear function, to have 2 solutions, 1 solution, or no solutions. So they could intersect twice, once, or none at all. So that's if they just give me the equations and say, figure out the intersection points or the system, the solution. But that's not the only time we could see these types of problems. So now I have, I think, 3 word problems. Yeah, I have 3 word problems that we're going to look at together. The first one is talking about revenue and cost for a school play. So our goal is to determine the ticket price that will allow the drama club to break even. So the first thing I have to figure out is, what does it mean for the drama club to break even? Revenue is the money that comes in. That's the money that we earn putting on this production based on the ticket cost. But the cost to actually let the play happen, like the building materials and the costumes and having the electricity running and turning on the stage lights and all of that, that's also going to play a part in what happens with that money that comes in. So if we're going to break even, what we're looking for is when our revenue function is equal to our cost function. I'm looking for the intersection between these 2 equations. So I already have this graphed on Desmos, but you can do this along with me. You'll notice that where my graph is right now, I can't see what I'm looking for. So I'm going to start zooming out. And as I'm zooming out, I'm noticing this is not helpful to me at all, because I can't really see well what's happening. So you have a couple options. You could come up here to this settings bar and you could change your X and Y axis here, or you can pull your graph down a little bit and start to zoom back in on that one spot. And I'm just using my mouse, the scroller on my mouse. So now there is one possibility up here, right? They intersect at the vertex here. So one of my ticket prices, because ticket is the X value, would be 3. So I could charge $3 to break even, where revenue and cost both are the same amount of money. But that wasn't the only one. If you look down, sorry, I'm trying to get Desmos to agree with me. If you keep moving your graph down, there's another point right here. If you want to zoom in a little bit more to see it a little bit better, you can. But ultimately, this other intersection point, and if you just click on these, it'll show you the intersection point. You don't have to be perfect with your clicking. So I could charge $3 or $4, and these 2 equations would end up being equal. The amount of money that comes in for my revenue would be the same amount of money that I would spend as my cost. So $3 or $4 would allow us to break even. The next question, question number 5, is dealing with a local business that's selling 2 different products. So they have weekly sales that are modeled by an exponential function, and then they have weekly sales that are represented by a linear function. And it says, after approximately how many weeks will the sales of these 2 products be the same? This word right here tells me it's probably not going to be a whole number answer, and I have to do my best to round or estimate. Since we have Desmos, we don't have to estimate. So I have these 2 graphed already here. Again, this is one of those scenarios that I can't see what's going on. Now I found an intersection point here. This is negative 5.18. But my X value represents weeks. It will not make sense for me to give a negative solution because I can't have negative weeks. So that's when I need to click and drag and move my Desmos graph to the positive solution. Now it said approximately. You could use 21. However, it is closer to 20 weeks because this would round me down to 20. So if I was being as accurate as possible, I would say that this answer should be 20 weeks. Because that decimal is much closer to 20 weeks than it is to 21 weeks. So the last question we're going to look at doesn't actually give us our equations yet. So we have to do a little bit of work first. So the first thing I'm going to look at, there's two different types of bacteria. So I'm going to label bacteria 1 and bacteria 2. These are going to be my two equations that I'm writing. The original number of bacteria in the first sample was 3. So I'm going to put that in there. And the second started with 700. So those are both my initial amounts. The second sentence tells me the first bacteria doubles in size every day. This word makes my brain think exponential functions. So since it says doubling, I know that my ratio is going to be 2 because that represents doubling. And it's every 1 day. So my exponent is just x. My second type of bacteria increases by 20 every day. That is a keyword to tell me that this is a linear function. So 20 is my common difference, and that's happening every day. So then that's going to be increasing by 20 every day. So I put these two equations into my Desmos graph already. Now again, you'll notice I can't see everything I need to. So I'm going to start zooming out to see if I can find when these intersect. Here's one, but X represents days, and I can't have negative days. So I'm going to scroll out a little bit more, and I'm going to pull my graph down and see that somewhere right about here is my intersection point. Now it says after about how many days will these two bacteria have the same number? Well, I'm way closer to 8 days than I am to 9 days, so that's going to be my answer, 8 days. So based on these two equations, it's about 8 days for them to be equal or equivalent.